Hello, welcome to Getting Started, Part 3 of Shed Math. Overview, we're going to cover, this lesson picks up where Part 2 ends. We will discuss what pitch of a roof is. You will determine and record the scale factor you will use for the project. You will calculate the length of your rafter. You will calculate the length of all of the framing to the nearest 1/16 of an inch, and you'll cut all your framing to size. In order, you'll determine your scale factor, the length of your rafters, the length of your scale shed parts, and you'll cut your parts for your scale shed. You'll be able to calculate the length of your scale shed after using the rafter using the Pythagorean theorem to the nearest 1/16 of an inch. You will determine an appropriate scale, accurately calculate the length of your scale model parts, and accurately cut your shed parts to within 1/16 of an inch. What is the pitch of a roof? Simply put, pitch is the slope of your roof, how steep it is. Pitch is always expressed as some number over 12 inches. For the next example, we will use a 6/12 pitch, meaning the roof rises 6 inches for every 12 inches of run. Rise over run, 6/12. That is your steepness of the pitch for this example. How to calculate the length of a rafter. Look at this for a second. Do you realize you have enough information to figure out what the length of that rafter is? Well, first thing we do is I'm coming down here, creating a triangle. This is exactly half the length there. That's how I got the 72, is just half of 144. This is the pitch. And I created a little triangle, up 6/12, and then you can connect the lines. We now have two triangles, one large, one small. What do you notice about them? These triangles are similar. They are different sizes, but have the same shape. Now, I rearranged the triangles to match the corresponding sides. Long side on the bottom, short side on the left, and there's our hypotenuse. I need to find that leg, B. I'm going to use a technique that they showed us in the video by using the scale factor. Well, I know that 12 and 72 correspond. And I know that they're similar. So I can ask the question, what number times 12 will get me 72? Or in other words, saying 12 times x, or 12 times what number gives me 72? I know that 6 times 12 equals 72. Therefore, our scale factor is 6, because 6 times 12 is 72. Next, solve for b. This number, 6, times our scale factor of 6, will equal the length of b. So 6 times our scale factor, 6, is 36. Thus, the length of this leg of the triangle right here is 36. So now I have this triangle, 36 and 72, and I have enough information now that I can use the Pythagorean theorem to figure out what the length of C is. A squared, which in this case is just 72 squared, plus b squared, which is 36, is going to give me c squared. Okay, just substituting in, do the math, add them together. I now know that c squared equals 6,480. To find c, I take the square root of both sides, and I know that c equals 80.498. You notice that we did not calculate the full length of the rafter. Why do you think this is? Right here. You will need to cut a notch at this location. The hypotenuse you just calculated is the location of the notch the location where the notch will be cut at. Notice from this point right here to that point, which is also the same thing as from here to right there. Now you need to calculate the length of the rest of the rafter from the edge of the wall to the end of the rafter. So I have another triangle here, and it's the same distance. So it's 24 inches here. We don't know what the rise is exactly yet, but we have this. We know these triangles are similar. Again, using similar triangles to solve for B, 12 and 24 are corresponding sides. What times 12 equals 24? We know that 2 times 12 equals 24, so our scale factor is 2. Solve for B. 2 times what? 2 times 6 gives me 12. Therefore, B is 12 inches. Now, using the Pythagorean theorem again, substituting in 12, 24, square them, add them together, gives you c squared equals 720. Find the square root of both sides. C equals 26.833. Last step, combine the lengths by adding them together. Convert to a mixed number with a fraction to the nearest 1/16 of an inch. Here are my numbers. I added them together. Consulting my conversion chart, the closest 1/16 of an inch is 5/16. Therefore, the length of my rafter on the bottom edge is 107 and 5/16. I kept the whole number and just add the fraction. Now, what if, it's kind of hard to see it, but what if your measurements were not easy multipliers? How would you find the scale factor? And you may very well end up with this on your shed, and that's why I'm showing this to you. So you need to focus here. They're still similar triangles, but what if the bottom was 12 and 15? You can simply set this up as an equation to find the scale factor. We know that 12 times some number will equal 15. We can write the equation as 12x equals 15. Now, I can balance this equation in order to isolate x on one side of the equal sign. Again, I'm just trying to find this value right here, so I need to move this 12 from over here to over here, so this is by itself. I'm isolating the x. The opposite or inverse operation of multiplication is division. So 12 times x divided by 12 equals 15 divided by 12, because I'm simply going to divide both this side and this side by 12 in order to cancel it out. Or if I write it in equation form, 12x divided by 12 equals 15 divided by 12. The 12's cancel it out, leave you x on one side. On the right side, 15 divided by 12, I get out my calculator, press the buttons, and I come up with 1.25. Therefore, x equals 1.25, and 1.25 is your scale factor. When you calculate your rafters, I recommend that you open this presentation when you have all your information and follow these steps. There are a lot of steps. Use this as a step-by-step guide to help you calculate your rafter length. Use a calculator, keep your notes, and stay organized. The next step, if you have not already done so, open and review all of the construction drawings in the construction drawings folder in the resource folder under syllabus and introduction. These are the plans you will use to build your shed. Become familiar with them. I designed a full-size shed. You will need to scale down the size of all parts by a selected scale factor. You need to choose a scale factor. You may not choose 1 to 8 because this is the scale factor that the teacher used or I used in developing my demonstration. But you can use any other scale factor, 1 to 10, 1 to 15, 1 to 20. But keep in mind, your shed still has to be small enough to carry by hand, yet big enough that you can build fairly easy and not deal with really small parts. Next, if you have not already done so, open the resource folder under Syllabus and Introduction. Open Part and Scale Calculation Worksheet with the parentheses Teacher. This is an example of the homework assignment that you are going to need to complete. I completed this worksheet with the scale as the teacher of 1 to 8. That's why you need to use different scale. For you, find the assignment in Module 1 titled Part and Scale Calculation Worksheet, parentheses Student. This is what you need to complete. It includes directions for the assignment. When complete, save your file as last name, Part and Scale Calculation Worksheet, date. For example, my last name is Pollard, so I would name the file Pollard, Part and Scale Calculation Worksheet, today's date. Then drag your file into the assignment Dropbox. Next, you're going to calculate the length of your rafter. This will also be a graded assignment. You'll find this assignment under the Module 1 folder. Open the Construction Drawings folder under Syllabus and Introduction and select 8 Shed-Rafter Assembly. You have enough information on this PDF to calculate the length of your rafter. Use diagrams and illustrations as necessary to show me your work. All work needs to be neat and orderly so I can follow it and that I can read your writing. You may show calculations by hand or on computer. If done by hand, I must be able to read your writing. When saving the file to turn in, save it as last name, rafter length, calculation, date. Again, drag your file into the Dropbox. You have calculated all of your part lengths to the nearest 1/16 of an inch. It is now time to cut your framing. For construction, I am concerned with the length of the framing. Based on what you use, the thickness and width will vary. For example, I used paint stirring sticks. The plans call for 2x4. Now I can measure an exact length, but it's not going to be the right thickness and it's not going to be the right width as far as the piece, but I'm going to use those to simulate 2x4s. That's fine. When I'm looking for the length of the individual parts, and for the shed I'm looking for the width, length, and height, that the exterior measurements are the right sizes. Make sure you clearly label every part. Your parts will become mixed up unless you are very careful. So in order to prevent placing the wrong parts in the wrong place in your building, make sure that every single part is clearly labeled so that when your parts inevitably get mixed up and you pull one out of a pile, you know exactly where it goes. You figure out the system, you figure out how you're going to label it. But every part needs to have a unique label that you know exactly where in the shed that particular part will go. I need you to take a photo of all your cut parts in a batch, and then I need you to take a photo of at least one part showing how you clearly labeled every part in your shed. On your part and scale calculation worksheet, you will notice 3 parts highlighted in yellow. You need to take a photo of these 3 parts showing them clearly labeled and measured. Your parts should be within plus or minus 1/16 of an inch of what you call out on your worksheet. Following are examples of what I'm looking for from you. Create a file and title it last name, photo of parts, date, and place in the assignment Dropbox. Here's an example of the parts that I cut. Can't see specifically, but you can notice I got pin writing on every single part. These, like, barely see it here. You can see them here, here. I developed my own system. I labeled them in a particular way, and so when these parts inevitably get mixed up, I know exactly where they belong as I pull them out of a mixed up pile. Now notice stud, scaled length, 11 10/16 or 11 5/8. Okay. You see the end of the part right about here. That's 10/16, just a hair under. So, but it's within a 1/16 of an inch of what I called out, so that's acceptable. Likewise, this is a picture of one of my parts with a clear label, base beam. I know what that means. If it gets mixed up, I pull it out. I know exactly where the base beam goes. It goes into the base assembly, and it's a longitudinal beam. And it's according to my scale, off my sheet as a teacher, I came up with 24 inches. And there it is. This one's almost right exactly on 24 inches. And again, clearly labeled, scaled length, 10 3/16. Now notice when I'm taking the photo here, I'm taking a photo directly above it. I'm not standing at an angle or allowing the photo to be distorted. When you're taking photos, you need to be directly at a right angle, or if it's facing down, you need to be directly above it, so that when you get a photo, you get an accurate reading of the ruler or tape measure that you're using. If you're off to the side, it'll give you a distorted vision or distorted reading, and you will not be able to read your ruler accurately. So when taking your photos, make sure you're straight up and down or at a as close to a 90-degree angle as you can get. This is the end of the lesson of Getting Started Part 3. We discussed what pitch is. I demonstrated how to calculate the length of your rafters using the Pythagorean theorem. You chose a scale factor and calculated the length of your scale shed parts, and you started or should be starting to cut your framing to size at this time. This is the end of Module 1, Getting Started. In this module, we learned about multiple math concepts, including linear measurement, scale, similar triangles, calculating the leg lengths of similar triangles, and the Pythagorean theorem, including exponents and roots. You cut all of the framing parts you will need for your scale shed assembly. Next, in Module 2, Build the Shed, you will construct your model shed using the parts you just created in this module. This concludes Module 1. See you in Module 2.